Today we're going to be looking at lesson 3.4, intercepts of graphs. So we have our vocabulary words. So make sure you look at your vocabulary sheet and define each of these words. Let's take a look at example 1, intercepts of the graph of a linear function. So we want to use this graph to find our x-intercept and our y-intercept. And then we want to describe where the function is positive and negative. So let's go ahead and find the x-intercept, the point where the line crosses the x-axis at. And it's going to be right here, and that's 1, 2, 3. So the x-intercept is at 3, 0. So for x-intercept, the y is going to equal 0. For y-intercept, the x is going to equal 0. So that's going to be right here for the y-intercept, and that's 1, 2, 3, 4, 5, 6. So that's going to be at 0, 6. Now we want to describe where this graph is positive and negative. So a function is positive when its graph lies above the x-axis. So the function is positive when the graph is above x-axis. So x values are greater than or less than 3. Or less than 3, because if it's greater than 3, then it's going to be negative. And then the function is negative when the graph is below the x-axis, as we said, when x values are greater than 3. All right, let's take a look at example 2. Intercepts of the graph of a nonlinear function. So it's nonlinear because it has a nice curve going on. So we want to find the x-intercept. We can always use int for intercept. The y-intercept. We want to see when is it positive and when is it negative. So let's find the x-intercept, the point where y equals 0. Well, in this problem, there's actually going to be two different x-intercepts because it crosses the x-axis right here, and then it crosses it again over here. So the x-intercepts are at -4, 0, and 3, 0, because it crosses twice. The y-intercept is when the x value equals 0 and it's crossing the y-axis at, and that's going to be down here. So the y-intercept, the x equals 0, and our y value is -12. Well, when is this going to be positive? So it's positive when x is less than -4. So that's all the values over here. And it becomes positive again over on this side when x is greater than 3. When is it negative? Well, that's going to be the time in between. X is between -4 and 3. So all this time right here, it's going to be negative. Over here and over here, it's going to be positive. Let's take a look at example 3. Find the intercepts of the graph. So the graph shows the height of a ball for each second x that it is airborne. Use the graph to estimate the x and y intercepts. So we want to find x-intercepts and y-intercepts. Again, INT stands for intercept. Where's the function positive and negative? So the x-intercept, the point where the line crosses the x-axis at, is right here. So that's going to be at 9, 0. The point where the line crosses the y-axis is right here. So it's going to be at 0, 4. Again, I look at my x-axis for my x-intercept, my y-axis for my y-intercept. Now I want to figure out, when is this positive? And the function is positive when x is between 0 and 9. So when x is between 0 and 9. We don't have anything else for this graph after that, so we don't have any negative part. No negative part. So we've looked at a graph. Next, let's look at a table. So we want to find the intercepts from the table. So we're going to start off with the x-intercept. The y-intercept. So x-intercept, the point where the y equals 0. So y equals 0 down here. So that means my x-intercept is at 40. My y-intercept is when x equals 0, which is up here. So my y-intercept is going to be 0, 140. So in this situation, what do these mean? Well, at day 0, the balance that we have is $150. After 40 days, we have a balance of $0. So after 40 days, we've spent all $150 that we had in this account. That's what those intercepts stand for in this problem. So let's take a look at example 5. So we want to solve a linear equation by graphing. So we're going to find our x-intercept and our y-intercept. So let's take a look at the first one. So I got some stuff over here. Let's move it to the other side. So let's subtract 1. Subtract 1. I get negative 2x plus 6 equals 0. So I want to graph the left side of the equation because our function is going to be f of x equals negative 2x plus 6. So our x-intercept is when y equals 0. So when y equals 0, what's x going to equal? Well, y equals 0, so x is going to be 3. Our y-intercept is when x equals 0. Well, what's our value going to be when x equals 0? Our value is going to be 6. So we're going to put a point at 3, and we're going to put a point at 6. Again, how do I get the two of those? My x-intercept is 0 equals negative 2x plus 6. Solve this equation. You're going to subtract 6, get negative 2x equals negative 6, so x equals 3. And then our y-intercept is y equals 2 times 0. plus 6. So y equals 6. That's how I got the two of them. That's not a great line. Start there, go there. Again, not a great line. Let's just try it as best we can. It's not the straightest, but there we go. There's our line. Now let's take a look at example 6. So solve x squared minus 4x equals 3 by graphing. So let's go ahead and graph this out. So just like I did in the previous one, what I want to do is I want to get the 3 to the other side. So I'm going to add 3. I'm going to add 3. That gives me f of x, which we can say is y, equals x squared minus 4x plus 3. So now we want to graph this out. So where's my x's going to be? My x-intercepts. And where are my y-intercepts going to be? So my x-intercepts, I'm going to have two of them because this is a nonlinear. So one of them is going to be at 1, 0. And one of them is going to be at 3, 0. My y-intercepts is going to be at 3. So y-intercepts at 3. One of my x's is at 1, and one of my x's is at 3. So it's going to come down, around, and then back up. Let's take a look at the next one. So we want to graph the equation of a horizontal line. So we want to get these over to the other side. So I'm going to start off with adding 5 to both sides, plus 5, plus 5. I get 4x plus 8 equals 4x. Now I want to get this to the other side. Subtract 4x, subtract 4x. I get 8 equals 0. Well, this doesn't work, so I know I have no slope. So we're going to have a horizontal line crossed 8, right below 10, right there. Horizontal line at 8. And that's how you would work out these problems.